Let's try to prove something interesting using the triangle inequality theorem. Let this be a random triangle ABC. We have drawn a line from vertex A onto BC and let us name it AD. Note that D can be anywhere on the segment BC. We have to prove that the sum of all three sides is greater than twice the length of AD. Remember, D can be any point on BC. How do we do this? Let's write down what we need to prove. The sum of all three sides is AB plus BC plus AC. We have to prove that this is greater than 2 times AD. The moment we see such a problem wherein we have to prove that the sum of sides is greater than something, we should realize that we may have to use the triangle inequality theorem. So we can see two triangles here, triangle ABD and triangle ADC. In triangle ABD, we can say that AB plus BD will be greater than AD. Sum of these two sides will be greater than this side. And in triangle ADC, AC plus DC is greater than AD. Why did we choose these specific combinations? It's because we wanted to have AD on one side of the inequality. We have two inequalities here, but first let's understand something very basic. Consider two random inequalities. Say 5 is greater than 4 and 3 is greater than 2. Then 5 plus 3 will surely be greater than 4 plus 2. 8 is greater than 6. Sum of left-hand sides will also be greater than the sum of right-hand sides. Also, if 10 is greater than 9 and 17 is greater than 12, then 10 plus 17 will be greater than 9 plus 12. This is true when the direction of inequality is the same. Now let's go back to our problem. Looking at these two inequalities, which have the same direction, we can say that AB plus BD plus AC plus DC is greater than AD plus AD. We're almost there. The right-hand side is 2AD. We know that BD and DC form BC. So we can group them and write it as AB plus BD plus DC plus AC is greater than twice AD. Looking at the figure, we can see that BD plus DC is BC. So this can be written as AB plus BC plus AC. The sum of the three sides is greater than 2AD. You may draw a segment from any vertex to a point on the side opposite that vertex. The sum of all three sides will definitely be greater than twice the length of that segment.